Hi viewers, this is Sri Ramulu. So today's topic is London's equations. H London and F London derived equation for superconductor. In superconductor, paid electrons are responsible for the electricity. When the temperature is increased above critical temperature, superconductor converted into normal conductor, right? So London equations, London's means there are the two scientists, or I think they are friends, they are uh, brothers, H London and F London derived equation for superconductors, right? So in the form of current density they have derived equation. In superconductor, paid electrons are responsible for electricity. Generally, if we take normal conductor, in normal conductor, free electrons means single electrons is responsible for conduction of electricity. But in superconductors, paid electrons are responsible for electricity. For responsible means of producing electricity. When the temperature is increased above the critical temperature, superconductor converted into normal conductor, right? So suppose if it is a superconductor, in the superconductor paid electrons present, if you increase the temperature to this superconductor, then bond will break between the paid electrons, then paid electrons become free electrons. So when the paid electron converted into free electrons, then that superconductor also converted into normal conductor. Then paid electrons becomes free electrons. Paid electrons becomes free electrons. So the like this bond between the two electrons will break and becomes single electrons or free electrons. The force on electron due to electric field is given by, see here. So already we know the relation between the force and electric field like this. F is equals to minus e. Minus indicates electrons or negatively charged. Let it is a equation 1. Now what happens in the superconductor? Electrons paid will start moving. So moving electron means it comes under motion, equation of motion of superconductors electrons. So equation of motion is what? F is equals to m into dv by dt. Generally, what is the formula for the force? According to Newton's second law, okay, according to equation of motion, or simply we can say Newton's second law, it is right. Equation of motion of superconductors, or we can say it is Newton second law. So Newton second law is, we know that is F is equals to ma. A can be written as d square x by dt square, that is in terms of distance, or in terms of velocity A can be written as dv by dt. So ma means it is m into dv by dt. So like this, m into dv by dt. So it is simply acceleration. So force is equals to mass into acceleration. It is Newton's second law. Now if you observe the equation 1 and 2, so it is a force, this is also force, make these two equations are equal. So yes, written, and bring m that side. So it is now multiplying. If you bring that side, hit this side, it divides. Yes, let it is the equation 3rd. Differentiating equation, supercurrent density. So current density means what? Generally supercurrent is denoted by is. So supercurrent means superconductor current. So current by area, simply we called current density. Generally current by area is current density. Supercurrent by area is supercurrent density. We write it is Js. Js is supercurrent density. S indicates super, is equals to NSEB, where here NS means it is a number of super electrons per unit volume. Number of super electrons per unit volume, or it is a density, volume density, superconductor volume density. E is the charge of the electron, V is the velocity. So it is Js is equals to minus ns e v. Minus is because of electron. Why? Because in superconductor only electrons will be there. Now differentiating equation 4. Generally this is the equation 4. Now differentiate equation 4. Then what we get? Delta Js. See here above, differentiating above equation. Differentiating equation 4. So it is equation 4. Write both side d by dt. This side also d by dt. Then what you get? This equation we get. Right? So if you differentiate, what is J is equals to minus ns ev. Differentiation with respect to time, djs by dt is equals to, it is constant, it is constant, it is this one only differentiable. So ns e dv by dt. So like this, it is equation 5. Right? Equation 5. And now we know the dv by dt from the equation 4. What is the equation 4c? Equation 4 is dv by dt minus e by m. Right? Minus e by m is substituted here. Now this minus become plus, e into e square by m into e. Okay. Let it is equation 6. So this equation 6 is called London's first equation. Okay, so equation 6 is called London first equation. And now what we have to do for deriving second equation? So if you want to derive the second equation, what we have to do? We have to take curl on both sides. Taking curl on both sides of the above equation 6. So taking curl means it is del cross. Del cross is called curl. Okay. So del cross this is equals to del cross into this. Okay. Both side del cross is applied. And here d by dt take outside and multiply del inside, it becomes like this. And here these two things bring outside with m, then del cross E will be inside. From Maxwell equation. So in the Maxwell there are 4 equations are there. So but one equation is with the electric field. That equation is what? Del cross E. Del cross E is what? Minus dB by dt, or we write dou B by dt also. Minus dou B by dt or dB by dt. It is a Maxwell, one of the Maxwell's equations. So here what? Del cross E is equals to minus dB by dt. So in the place of this, substitute this one. Yes, substituted. And the remaining things are same. Okay, so it is same and this is same. Right? It is this. So only in the bracket we have substituted. And here no minus this side, but because of this minus will come outside. And it is as it is, copy pasted. Okay. Now what we have to do? Now we have to integrate on both sides. Okay, after taking curl, we have to integrate on both sides. So integrating above equation with respect to time. Okay. So here to this equation we are integrating. So just to integration dt we have to multiply. So integration left side, dt is right side. Okay. So integration left side and dt is right side. Integration is left side, dt is right side. Okay, to the above equation. Okay. Now here dt cancel, right? dt for integration, differentiation will cancel. Okay, so only this box will remain. Okay, once again this and this gets cancelled. For integration, for differentiation, integration both cancel. Why? These two are reciprocal. Integration is equal to 1 by differentiation is always. So that is why these two gets cancelled. Okay, right? So this is like this, and now this differentiate dt and this dt gets cancelled, and this is completely constant. Take outside with a minus. Okay, minus is already outside is written. Okay, inside is integration b naught to b and a db will remains. Once again see, dt cancel, and this part is taken outside. Okay, then integration and db remains there. Okay, now, so nothing means what you have to understand here. One integration of 1 with respect to dx is what we write simply x, but here in the place of x what you have, b you have. So integration of 1 with respect to b we write simply b. Okay, so here but limits where to where, b not to b, right? B not to b. Now see, this is, and it is again written one more time, so it is a waste of time, I think. Okay, now, so it is integrated, right? After integration what we have to substitute, limits. How we substitute limit here, let me explain in general. If it is a x, what I got x, where to where, from a to b limits with limit, then first substitute b and write minus, and later substitute a in the place of x, like this, b minus a. In the same manner apply here. First keep b in the place of b, after minus keep b naught in the place of b naught. Okay, and from Meissner effect b naught is equals to 0. From Meissner effect b naught is equals to 0 means Meissner effect, what it explained to us, when a superconductor is cooled in the presence of magnetic field, when magnetic field reaches to the particular value, then magnetic lines of forces cannot penetrate through the substance. Cannot penetrating through the substance means magnetic field cannot present inside it, so its value is 0. So that is why in the place of b naught simply write 0, so written 0. Then what we get finally, so we get this equation is called London's second equation, right? So this is a London second equation, and if you observe London's first equation here, you may get here e value, second value is b value. Now once again check it, but cross product you cannot get, their differentiation you can get. Once again see here, this is djs by dt is equals to ns e square by m into b. So this part is same, but here instead of e and b are different, but here they are curl, here we have differentiation. Okay, see, this is. So okay friends, thank you. So don't forget subscribing this video.